In this lesson, we're going to create platforms in the game world sort of procedurally. Now, procedural design is sort of a buzzword that you've probably been hearing a lot of lately. Well, the idea has been around for quite a while, but nowadays it usually means a world that's being dynamically populated so that you're unlikely to get the exact same experience twice. Well, by those standards, what we're going to be doing this lesson is not truly procedural, but rather a simplification of the general idea, which is basically to set the conditions in code that allow for some sort of controlled randomness. That's essentially all that procedurally generating stuff in games is all about. So this will go into a bit of procedural design as well as specifically how to create platforms with unique attributes like physics materials and something called effectors, right? So I'll show you all that in a moment, but first let's start by importing some assets. So we'll create a new folder, call it world, sort of arbitrarily, and here we'll import our asset images for platforms. So we'll have a rubber platform, you can probably guess at how that's going to behave, a soft platform, and a stone platform. And as usual, set that to point. All right, so we're going to want to create prefabs out of each one of these platforms as our base game objects that we'll be using to instantiate from. So let's start off by creating a temporary game object for each of these prefabs. So we'll say platform grassy for this game object. Zero out these values. Put on the background sorting layer, sort of for no particular reason. We'll put on order 25 to make sure it stands out. And we'll give it a box collider. And we'll say used by Effector, and we'll see this in action in a moment here. See, it gives us a little warning that we need an Effector essentially, which we'll do in a second. So first we'll size it by giving it this X and Y value. Now we'll have to add an effector, so add that platform effector 2D. So we'll use a collider mask and set here what it collides with, the platform. So we'll collide it with our cheese head as well as our eyeballs. We'll set this to 0 for surface arc. Actually, surface arc should be 180. And I'll show you in a moment what this will do. Basically, what it'll do is it will allow the cheese head to, or the eyeball for that matter, to pass through the platform going from the bottom up, so jumping upwards, which is a common mechanic in platformers, but not going from the top down. So in other words, we can land on the platform and jump up through it. So, and I can jump through it on the way up. See? And that's the usefulness of the effector. So actually copy this as the basis for the other game object. Actually, this should be zeroed out. This will be the rubber platform. So we'll say platform rubber. So now what we're going to do is apply a physics material to this platform, which is just a handy and easy way to add some behavior easily to a physics object. So in this case, bounciness. So we have to create that material first and then add it to the box collider's material slot here. So I'm going to create a new folder, keep this organized, call it materials. and I'm going to create a physics 2D material. Call this bouncy, and we'll give it 0 friction and bounciness value of 1.1. You can experiment with this and see what it does, how much more bounciness it gives it. And for testing, just to show you how this will be, and we can just assign this to the physics material for the box collider. There you go, it gives us an automatic bounciness. All right, pretty cool. And we'll copy this. Call this one Stony. So we'll give it the stone platform, take away the bounciness, and for this one actually we won't use the effector because we just want it to be a solid platform. So just as we'd expect, and enter it from the bottom. Oh, we're getting stuck there. So, as you remember maybe before, we turned this into prefabs by, well, we'll create a prefabs folder and just click and drag to create our sort of bundled up game object with all these components. So that one, this one, and the stone platform, there's our prefabs. We can get rid of these now. We don't need them. So we'll want to randomly instantiate these platforms whenever a floor game object is created. So let's create and attach to the floor game object a script called platform factory that we'll actually create in scripts world folder. We'll say platform factory. So first thing we'll do is grab a reference to these prefabs as the basis that will randomize which one we'll actually instantiate. And we'll set this in the inspector. So say Stony platform. That's why I'm marking this as public, so we can do this in inspector. Grassy platform and rubber platform. And back in the inspector, on the floor game object, we'll put this. It's going to want those game objects, so in the prefabs folder, just click and drag Stony, Grassy, and Rubber, no particular order. Now with this, we'll set out to create a sort of grid-like setup of all the possible positions that a random platform can be instantiated in. So to do this, we're going to use the simplest type of multi-dimensional array that is available to us, a two-dimensional array. It sounds kind of scary maybe, but it's not. It's actually pretty simple if you already understand arrays. A two-dimensional array is not too difficult to wrap your head around. So basically all that it means is that it's an array, and at each index of that array, it stores another array, right? Hence 2 dimensions. So, and that array at those indexes also have their own indexes. You can visualize this actually much better than the way I'm describing it as a common table-like structure, like a spreadsheet or a multiplication table. And so we'll be using this inherent structure of the array and sort of actually have a visualization of it with our platforms taking up spots in each section or cell of that grid-like structure. So for our multi-dimensional array, let's initialize it here in start. So this is how you initialize a multi-dimensional array. So it's going to be an array of vector 3s for possible positions, right? So in an ordinary array, we'd have this sort of box-like looking syntax here to signify a single dimensional array, in other words, whereas for a two-dimensional array, we use a comma to signify two levels of the array. And if it was three-dimensional, we add a comma, and so on and so forth. So it may look a little wonky, but it's not too hard to wrap your head around. So it's a two-dimensional vector 3 array. We'll call it possible positions. We'll assign to it, or we'll actually initialize the two-dimensional array to a vector 3 of 5 indexes on the first level arrays, and each index of those 5 indexes has 3 indexes, right? So again, I'll give you a visual for this. It'll be easier to visualize it as a table-like structure. And we'll say float y position. I'm going to sort of hammer out a bunch of code, not explain too much of this. I'll try to explain what I can. So y position is minus 2f, and float x position is minus 3.6f. And we'll say int max rows equals 5, int max columns equals 3. All right, so we'll set up a for loop now to populate this array of possible positions. So we'll say for int I equals 0, if I is less than max rows, which is 5, we increment I. And then within this for loop, we have another for loop. So this is especially useful when doing things like multi-dimensional arrays. So it'll look a little funny, but if you do this a couple times, you'll get used to this. This is just pretty much one way of doing it, and the easiest that I find is to do setting the values for the multi-dimensional arrays. So we'll have, for this for loop, int n for the incrementer, n, if n is less than max columns, n++. And then here, finally, what we'll do is we'll set possible positions, and this is all going to increment. So the first pass through will go once through this for loop, and this will be, say, 0. So first we'll set 0, and then n will also be 0 the first pass through. Sorry, I'm not actually going to write 0. I'm going to say I and n, because this is going to change as it's incrementing through the for loop. Say new vector 3 transform position dot x plus x position. So basically, it's going to create platforms at consistent places on the screen relative to the platform's position, and you're going to have basically this grid-like structure that I'll show here. And that's what we're setting here with this code. So y position and 1 for the z value. So you can imagine as this is iterating through these for loops, the first time it goes through, it'll set at the 0, 0 index the vector 3 to this position, whatever's calculated here. And then the next pass through is going to be 0, 1. It's going to set another vector 3, and then 0, 2, and 0, well, I guess there's only 3 indexes there. So, and then it'll move down or move back to this for loop, and it will have at the 1 index, 1, 0, so possible positions 1, 0, it'll have another vector 3, and it'll go through this iterative process until we're finally done with all those iterations. As it's iterating, we'll change the x position. So we'll say x position plus equals, we'll do a little ternary. If x position is equivalent to 3.6f, which is basically the furthest platform to the right, then we'll reset it back to minus 3.6. So we'll just say plus equals minus 7.2, which will reset it back to that. Kind of a funny way of doing it, but that's the way I want to do it. So basically it'll be either minus 3.6 when it goes through one iteration, 0 as will plus equal 3.6 on the next iteration, then finally 3.6. After that, it will plus equal minus 7.2 to bring us right back to minus 3.6 when it goes on to the next, I guess it would be row, platform row. Yeah. So, and we'll do something similar, a similar type of thing with the Y position. We'll say plus equals 1.5F. And then we'll have a single dimensional array of platform game objects to choose from. So for that, we'll just say game object, an array of game objects, that's square syntax, and we'll say random platforms, and we'll say equals new game object. And of course, there'll be 3 platforms in the array. And this will be a different way of initializing the array. This is called a array initializer. So it's an easier way of doing this. We could just set each indexer 0, 1, and 2, or we can just do it this way. Have these curly brackets, and then for the 0 index, put in stony platform. And for the 1 index, it's implied that this is the 1 index, and the other one's the 0 index, grassy platform for that one, and rubber platform for the second implied index. All right, that's an array initializer. You can also do this with objects and object initializers, pretty much the same kind of syntax. I'll just put a little comment here. All right. We're not going to need update. We're just going to want to instantiate this once, so all we need is start every time a floor platform is being made, in other words. So now we're going to use one of 2 possible methods of creating these platforms. One is more patterned, the other one more chaotic. So we'll start off with the patterned version first. Say private void create patterned. And it will take in the multi-dimensional array, vector 3 array of possible positions. Let's give it a variable local to this that we pass in at the call. We'll also want the array of game objects to determine exactly what kind of platform randomly we want to instantiate. So this is just going to be a simple little algorithm, I guess you could say, to instantiate platforms randomly, but to favor a more patterned appearance. So we'll kind of create like this dice roll effect. So we'll start off with int %chance. We'll start off with 75. This will change as we're iterating through our created platforms. I will say for each vector 3 will take the possible position. So we'll say for each actual position in possible positions, we'll roll the dice. Say int dice roll equals random dot range. This will give us basically a percentage chance. So we'll say out of 1 to 100, we'll roll the dice, 100-sided dice, I guess you could say. And if dice roll is less than percent chance, so if it's less than 75 at this iteration point, we'll make a created platform. We'll say GameObject.instantiate. We'll say random platforms, which is an array. So there's 3 in the index. So we'll have a random. We'll select a random one. So with random range 0, 3. So that'll be 0, 1, or 2. 3 is exclusive. Remember. We'll pass that right into that method right into the indexer. So it'll return either 0, 1, or 2. And we'll instantiate it at the actual position. And we'll have to give it a transform rotation by default. And we can't convert type object to game object, so we need to cast this as follows. Just cast the object that's returned to game object like that. And that reference to the created platform we'll use here to parent it to the floor game object. And we'll decrease the percent chance for each created platform. So this sort of disfavors platforms that are created higher in the index as it iterates through it of the multidimensional array. And actually it will decrease regardless. It'll decrease more if it's created the platform than if it didn't, but nonetheless it still will decrease the chance of a platform created at higher levels by writing that outside of the conditional. Oh, kind of made a mistake there. Random.range. Guess there used to be a method called random range. And now we'll create a more chaotic type of method. So private void create chaotic. It'll be the same thing here for input parameters. Actually, I got this backwards. This is the more chaotic one, actually. So just rename these. This will be create patterned, and the other one up here that we just wrote is create chaotic. Right? This is a more patterned kind of approach. And we'll say int pattern counter. Set that to 0. Say int even or odd equals random.range. We'll say for each vector 3, same thing, actual position. I'll just grab this because I'm lazy. For each actual position and possible position, this time we'll use this kind of way of instantiating a platform. So if pattern counter mod 2 is equivalent to even or odd, so this will be random, either 0 or 1, and pattern counter is less than random range 5 to 15. I guess there's going to be 15 platforms in total. Copy and paste from before. Same way of instantiating. We'll take the pattern counter and increment it. So if you look at how this method's working, you can probably pick it apart. I don't really want to delve too deep into it. So now we'll also randomly call one or the other of these two different methods of creating platforms. So we'll do that over here under the array initializer. We'll say if pattern Actually, first we'll need an int, so we'll say int pattern or random equals random.range. Getting a lot of mileage out of this random.range method, huh? We'll say if pattern random is less than 3. So this will favor a create pattern method, because it's more likely that you'll have a random range that's less than 3. Pass in possible positions, random platforms, else we'll create chaotic. The same passed in. All right, so we'll test this out, make sure our platforms are properly randomizing. That must be the more chaotic type. Now, you're not going to be noticing it, but what's happening is each floor game object, it's copying over the previously instantiated platform, so that's no good. So we're going to have to change that before we move forward. So in awake, what we'll do is we'll clear this out sort of with a clean slate, create our platform. So void awake, and we'll, just so it's obvious what's happening, when we come back to look at this later, I'll make a private method for this called private void clean slate, and we'll just iterate through those previously created platforms that from the duplicated floor game object, and we'll just destroy them. So we'll say for each transform child in transform destroy child.gameObject, and here we'll just call clean slate. Now it should never overlap with our previous platforms that we created. Whoa. The other thing we need to do is, I don't want platforms to instantiate when the game starts, so we'll just simply wrap all this into a conditional. So all this in start will say if transform.position.x is not equal to 0, which is basically at the start of the game, well, then and only then do we actually create these platforms and go through all this code. All right, so that's about it. We'll get everything wrapped up in the next lesson, so I'll see you there.